Okay, so let's get started. So hello everybody, thanks for having me. Today we're going to talk about building better APIs from Django to client libraries with OpenAPI. Before we start, I'm going to tell you a few things about myself. So I'm Harald. I am working as a Python technical lead at Anexia, and my main focus is on Python, DevOps, and artificial intelligence. Also, in my free time, I work on open source projects. I'm an open source maintainer. You can find all my work on GitHub. I also run a blog where I post about different technical topics. And also, sometimes I do photography, and I post my photos also online. What is our goal today? The idea is we want to build REST APIs and we want to make them better. And our main focus today will be on documentation. So we want to automate documentation, also the creation of client libraries. And we want to increase the compatibility of our API over time. In order to get started, let's look at an API lifecycle. So how can an API lifecycle look like? We will probably start by implementing some sort of design for the API. So the entire development team will maybe come together, talk about how the API should look like, and then they will start to develop it. And after the development, they will start testing it. They will create documentation. They will create the first deployment on different environments. The API will then be monitored, and depending on the outcome of the monitoring, we will maybe go back to development and maybe start to fix things, or if everything works well, we will maybe version the API, we'll move forward, and also create client libraries, as the API will be used by different devices or different applications. And at this point, we are also starting to think maybe about deprecations, and with this cycle we start all over again with designing and so forth. Okay, as you see, this requires a lot of skills depending on the area you are working on. So this also brings some of the pain points, and as I said at the beginning, those pain points will be the things that we are going to focus on. We have the documentation that we somehow need to keep track over time. We have the client libraries, depending on the sort of application we are building. And also, we need to focus on compatibility. And we see here the compatibility is really tied to the version and also to the deprecations that we are defining. In order to understand this better, let's build an API. I also created this. This is an open source repository you can access. The repository itself has different branches with each step in order to build the API. So if you want to reproduce this, you can use the compare function of GitHub for each branch and also follow the documentation. What we're actually doing, we're going to build an API using Django. Is anybody here using Django already? One person, two, okay. So Django is a Python framework for building full stack applications, but the framework can be also combined with extensions like Django REST Framework. And this is a stack that you can use in order to build REST APIs. And this looks pretty simple. You have to install those two dependencies. And the next step will be to create a Django project. The project that we are creating is a management for cars. So we will have a simple API where we are going to add cars, to add manufacturers and some features for the cars. And this is the command that you need in order to create your initial structure for the project once the dependencies are installed. And the next thing is you can go inside of this directory of your project, and Django has this concept of individual apps. And you can create one of these apps. And inside of these apps, you need to do also the installation. You add this to your global installed apps. And then we can go on by modeling our data. As I said before, we will have those 3 models. We will have our manufacturer, our cars, and our features. And each of those Django apps has a models PY. In the models PY, you're going to define how does your code look like. Django uses internally this concept of a data mapper, which means that your database is actually stored inside your code, so actually the definition of your database. And this will be synchronized to the structure of your database. When we start, we just have to create our 3 models. And the next thing is we are going to focus on the car model, because this is the one that's a bit more complex. We need to add our relations. This will have a relation to the manufacturer, where we are going to define a foreign key. And then also we have our features. The feature will be a many-to-many field. One thing that you also notice, you don't have to focus in Django on the back relations. They will be made automatically for you. And once you have defined the relations, you can go on and focus on the fields. You can define then each individual field of your models. When you're done with that, Django gives you this nice utility where you can run the make migration command. This will create your database migrations. So those will be Python files that will be part of your project that will define how the database will look like. We have a question here. This is similar to Alembic, which you can use together with SQL Alchemy.
Sorry, could you repeat the question for the stream?
Sorry, the question was if this is taking care of creating automatically the migrations. So basically, yes. Exactly. So actually, the migrate is afterwards. So you have to run this command separately, because the idea is the first command is actually creating your migration files. You have to decide how they should behave. Sometimes you also need to intervene and manually extend them, because there are several parts of those migrations that cannot be automized. Like if you are changing from a foreign key to a many-to-many field, the system doesn't really know how to move the data or similar things. Okay, also something that is important. This project that I also linked will use SQLite as the default database. If you want to use another database backend, just look in the documentation. There is also MySQL or PostgreSQL, which is supported by Django. Good. Once you've done this part, we're finished with the core Django components. The next things that we need to do is to define our serializers. The serializers, you can imagine them as the mappers on how your data will look to the public in your API. Also, you can define those 3 serializers that will be mapped to your model. You can then define in the meta class of each of the serializers to which model this is actually mapped. And then we have these fields definitions. For simplicity reasons, I just added the under all, which means it's going to expose automatically all the fields of your model. If you want to control this a bit more explicitly, you can define a tuple. And also what you can do, you can use sub-serialization, which means you can use the other serializers in your serializer if you want to display nested data. The next thing that you need to do now is to create the views for DRF. So now you kind of need to put together the data that is stored by Django and also how this should be forwarded to your public views. And this will only contain your query set information. So this is the moment where you can limit the amount of data that you go outside with. And also you assign here the serializer classes. And the last step is to now define your URLs, because each of your resources need to have an individual URL. And once you do that, you can do this using this router from Django REST Framework, which allows you to take each of the views and register them as part of your API, and the router can be finally added to your main application, so you will have everything under /API. Okay, and if everything is done, we can test this. So all you need to do is to take this run server command, which will start your application development server. And there we go. We're going to have an API. And what Django REST frameworks also give us is this browsable API, which allows you to also look at the data that is available in the system. This is a database where I already made some tests. So if you have this freshly put out, you will have no data here. Also, what you can do with the browsable API is also you can create data because it gives you some forms. So this is already pretty good. It's pretty decent. It's also something that others might be able to use if they are working with your API. But this is going to have some issues because now this is pretty tied to Django REST Framework. Also, this browsable API needs to be exposed in order to be available. So it kind of has some issues. What we can use instead is OpenAPI. Has anybody here used OpenAPI? Okay, we have a few hands, nice. So, for those that don't know it, OpenAPI is kind of a standard for documenting APIs. It gives you this nice single source of truth for how your API should look like. And we can look at an example. The OpenAPI documents can be either in YAML format or in JSON. And this one is one in YAML. When you start defining your API, you will tell which OpenAPI version you're using. So this is the version of the spec itself. And then you have the first few information in this info block where we have title and version. So this is the title of our project and also the version of our project. The next thing, we will have paths. So each path is a resource inside of your API. And now you also see a bit of a difference because we can now see each individual resource that we are having. Because in the browsable API, we've seen we have cars, we have features, we have manufacturer. And we'll also see here a bit more transparent that we also have detail endpoints. On each of those endpoints, we can now assign methods. And we can have methods on the list endpoint and methods on the detail endpoint. And these are kind of the default methods that Django REST Framework is assigning. So on the cars, we have a get for getting the list of all the cars and the post endpoint in order to create a new car. Similar on the detail endpoint, we see we have this ID. This ID can also be defined, we will see soon. So you can go on each endpoint and create a summary, so you can define a bit better what the endpoint is doing. You will have the parameters, so here we go back to the ID, which is also then specified. We can say in which format this ID should be. And then we can also define the responses. We can say we have a 200 response, and we have this reference to other components. So we can also specify very detailed how our responses should look like. We can also specify how our errors should look like. So in this case, this being a detail endpoint, if I have a wrong ID, I might also get a 404. So, main benefits, as I said, we have a single source of information for the definition of our API. And also, this is a document that is machine readable. So this means we can use it for generating documentation. We can create our client libraries, which we will see soon. Also, we can do compatibility testing, versioning, and much more. The question is now, how can we use this with DRF? We've seen we have made a lot of things automatically with DRF. We can go a step forward. There are libraries specifically for Django that allow us to create those OpenAPI specs based on the information that is already available. One of them is drf-spectacular, but this is generating the specs for an older version. As you see here, I also added the name Swagger. This is how this project was used to be known before. The current specs are OpenAPI 3.0 and 3.1, and those can be generated with drf-spectacular. A small notice, there was a built-in schema generator inside of the Django REST framework. This is now deprecated. And the documentation of Django REST framework is also forwarding to drf-spectacular in order to generate the specs. Okay, installation of drf-spectacular is as follows. Also, you add it to your dependencies. As typical inside of Django, once you have a project that uses management commands or it's doing something with a database, you need to add it to the installed apps. And in addition now, we need to go into the REST framework settings and also specify that we want to override the default schema class and add it to the drf-spectacular OpenAPI auto schema. And we have then also the option to extend how the meta information in this spec should look like. As we've seen before, we had the title and the version. We can specify this using the spectacular settings. And we can also add some additional information. I would highly recommend, if you're using this, take a look over the settings of drf-spectacular. And to generate a spec, all we need to do is just to run this command. And this is going to generate our OpenAPI YAML, and this is going to have all the information related to our API. What we also can do, related to the documentation part that I was specifying, we can use another tool, and this is the Swagger UI, in order to view the spec that we have. And I can run this command. So this one is now using a Docker container. The Docker container has all the dependencies already installed that are required. And I'm binding this Docker container to my current local directory as a volume in order to have this OpenAPI YAML. And I specify that the file that should be loaded now inside my Swagger UI should be my current local file. And this will allow me to also browse through my API, but now in a more common format, so everybody can now understand how the API should look and behave. And also, once I go inside of these details of the API, I can see how my endpoints look like. Also, I get examples because all these things are documented inside my API. I can also look at the schema, and I can see very detailed how my car is going to look like. I can also see how my manufacturer looks like if I open the right one, and there we go. And also I can see the features. I can see the features are a list, and I see each individual field. Okay. So the next thing that we can do using this spec that we have now available is generating clients. And the clients can now be either done in a classical way. Has anybody here used APIs to build a client for an application? Okay. So the classic way to do this is you will probably use a library like request or HTTPX if you are using Python, and you will manually code each of your requests. You will also create parsers and handlers in order to work with your data. You will then find out you need to handle pagination. You will also need to add the information for filters. And over time, you also need to update your API. So you also have to go again over your client and see what are the things that are now changed. The alternative is, let's use OpenAPI for this, because the documentation already has all the information that we need. And there is this project called OpenAPI Generator, which allows us to take the OpenAPI document as an input, and we can specify what type of client we want. And this is a nice way to automatically generate your code in a deterministic way, which will reduce errors. You have more time to focus on your actual application instead of just mapping data around. And as I said, once you have a new spec, you just regenerate your client and then you look over your definitions if everything is right. The OpenAPI Generator supports a lot of languages and a lot of frameworks. Just look over the documentation. And here we have a little example now, how we can run this in order to generate a Python client for our API that we currently have. As you see here, I just use this volume again in order to add my current file inside the container. I specify the version also of the OpenAPI generator, so those images are generated by the team that is maintaining the OpenAPI generator. I would highly recommend that you pin the version, because sometimes on major versions, they're really changing the structure of the projects. Then you define with your input parameter, which is your OpenAPI document, and you also specify the generator that you're using. In this case, we're using the Python generator, and you say what should be your output file. And once you are done with this, you have additional parameters which you can use specifically on the type of output project that you're having. So you have to look at the documentation of each generator because they differ. For Python, we can define something like a project name. You can define the package name. The package name is really important because this is how you're going to import your project afterwards. And you also can specify the version. If you are going to publish this project, this is really important because this is the version that's going to be used. And also, what's worth to specify is instead of using the local OpenAPI document, you can also use the document that is provided by a URL. So in case you're publishing your documents, like in this case, together with your releases, you can directly go and take the documents from your releases from GitHub. Okay, before we do this, let's just look at the generator example. So I have here the code for it. And I can simply run this script in order to create the client. And once this is done, we can look at our client, and this is the code that has been generated. And this has done a lot of things for us. It created the API in the first place. It created test cases for our API. So those test cases are automatically generated based on the examples that are provided. And also, we have documentation. And we have here the initial README file, which takes a moment to open. But in this README file, you see, you have specific instructions on how to use this, how you can get started with it. And also, you get detailed information about all the endpoints that you're having. And all this documentation is built automatically from your OpenAPI document. Okay, let's look a bit at an example on how to use this. Also, this is extracted from the documentation that has been generated. First of all, you have to import your library, and there is a configuration that you can provide. And this is also documented. So at this point here, you can specify what's the location of your API. It can either be locally, like in this case, if I run Django locally on localhost 8000, I can link it together, or I can have it somewhere public. And the next thing, I can now generate, I can create a context manager, and the context manager will now receive the information from my API configuration. And now I can select one of the APIs that I want to use. And I can now say, okay, what is the input for the object that I'm going to create? In this case, I select the manufacturer. I want to add a name, I want to add a country, and afterwards, I want to save it. And that's basically it. And also, you have the main advantage that the generator is currently bound with Pydantic. So this means you also get the type hints inside of your IDE for each of the endpoints that you're going to use. Okay, before we move to the compatibility, I just wanted to show that in the other repository, we have an example. So you can also use this together with the API. just look at this thing. Oh, it's not running anymore. Just a moment. So there we go. We have our API. As we see, we currently have 5 entries here. I'm just going to run this command, which is basically just going over the API. It creates a manufacturer. Once it created the manufacturer, it's also creating 3 features. And all these things are going to be assigned on a car instance that is going to be created. So if I open this, I see I have a new entry, and this is the car that has been created for us. Okay, then last but not least, we have schema compatibility. There are several tools that we can use for checking if our schema stays compatible. First one is OpenAPI Diff, which also comes from OpenAPI Tools, the team that is managing all those projects related to OpenAPI. There is also one other project that's worth mentioning. It's called OAS Diff. And you can use both of these projects using Docker containers. The main advantage using those with Docker containers is you don't have to worry about all the Java dependencies that are required in order to run them. Yeah, what you actually provide is the old specification and the new specification, and this will actually generate a diff and tell you if your project is still compatible or not. In a similar fashion, you can use the OS diff project and you can achieve kind of the same thing, but the outputs will differ. Let's look at a non-breaking change. So this is typical, something that will be added over time to an API. I choose an example now to add a rating field to our car model. So this is now nothing more, it's just an integer field that has now been added to this model. This means now when I extend this in Django, I will have to go over and run the make migrations command. It will generate me a new migration. I have to migrate my database and I will have this new field. Since I used the dunder all in the serializer, this field will be automatically forwarded to my API, and my schema generator will also take care that this field is going to be in the OpenAPI definition. And also, you will find this on the repository that I linked. There are a few versions of this API, and we have here the version 1 and version 2, which are now, version 1 is the initial API, version 2 is the API where we have this rating field. And what we can do now is we can run this command by providing these 2 specifications. And this will now tell us the entire difference between the 2 endpoints, or not the 2 endpoints, the 2 APIs and all the endpoints that are affected. And at the end, we will also get this nice report that is telling us if this API is now backwards compatible or not. And let's do another test now by adding a breaking change. So this is easier than most people will think. We're just going to rename a field. Instead of founded year, we're just going to call the field on manufacturer year. We also have to go to the entire process now of generating migrations, also migrating the database, but the rest will be taken care again by the framework. And if we are going to run this command now, we are going to see that things are going to change, because this time the API is not compatible anymore. And this is something that is really important. You have to think about it when you are creating something like a mobile app, where you are distributing the mobile app to multiple clients. Once you are doing such a change, you're basically breaking the app for everybody. And the nice thing about this CLI tooling is you can also integrate it in your development process. This way, you can also have it in your CI pipeline, and every time you implement a new feature or do a change, you will take care of this and you will not have a broken API. Okay, so we've covered a lot of things. We've built a small REST API using Django. We've documented this API using OpenAPI. We've generated multiple clients, or we generated just a Python client by, if you look in the repository, there are also examples on how to use this if you want with Rust or Angular or Go or whatever you want. And the command to build them will always be the same. You just change a few of the parameters. Let's just take the Go one. You see, the only thing that I did now, I specified that I want to have the client be written in Go. And if I now generate this, I will have the new project. And there we have it. And this will be now also available with an API, with the docs, and with the tests, but everything now made in Go. Okay, and the last thing that we looked at was the compatibility using OpenAPI diff. And that's all from my side. If you have any question, I'm happy to answer them.
I'll come with the mic. First question was here.
Yeah, hello. One question concerning the generated clients. Are there also other standards, and can you automatically transform the other standards to the OpenAPI client generator?
I'm not aware of any other standards, so the only one that I know is how the REST framework, so the Django REST framework used to do it using the browsable API. And this was kind of hard to translate this to other formats. So the only one that I'm really aware of is the OpenAPI standard.
Thanks for the presentation. I come from the Java world, and I use the OpenAPI Generator to generate both interfaces for the server side that I just then implement myself, and also generate the client the pretty same way as you did here. Here now is that Django does use a different library to generate the server side. So do you know a technical question there? Does this also use code generation, or does this during runtime read the OpenAPI specification to serve this API?
So in Django, I'm not exactly sure if I understood your question correctly. Those are all flows that are typically related to Django in order to build an API. And drf-spectacular is an addition on the framework to read all your existing configurations. So this will go over your model definitions and will extract as much data as possible from your models. It will look afterwards on your data, on your views inside the framework, and will try to generate as much data as possible from those views. So from your filters, serializers, pagination, and so on, it will try to extract as much as possible. Same thing will be with the authentication. If you have authentication layers inside the framework, there are middleware configurations for this. It will also look for those specific middlewares in order to extract the information. So this is basically an addition to the framework, because the framework itself had this ability to make all the database handling and so on. So the REST framework was an addition to add a nice way to build REST APIs, and then the other project was the addition to create the OpenAPI documents.
Another questions? Yeah.
Hello, thank you for your talk. Since you did all the configuration work for creating the OpenAPI spec, have you tried Fast API that basically does all of this out of the box?
Sure. I think those are different use cases. I was also thinking if I want to create an example using Fast API or using Django for this presentation. Actually, if you go at this part here, where we are actually starting to build clients from this part on, if you have the schema, this is agnostic, it doesn't matter. But the downside on fast API, I think, is the communication layer to the database. So you already have to put a lot of work in order to install SQL Alchemy. Also, if you want to have the migrations, you need to put a lot of work there to make it compatible with Alembic in order to have this automatic migration process. And for the most projects that we are using, we are actually relying on the admin panel. And I'm not sure if Fast API has anything similar to the admin UI that Django has.
Thanks for the presentation. It was great. I have a question to the APIs, especially for APIs for user-facing applications. There's a common pattern. First, you load all the data and display to the user, and then you get updates if something changes. Has OpenAPI some provisions for delivering updates and generating these APIs for the updates automatically?
That's a very good question. OpenAPI is really a standard for telling how your API behaves. There is a feature inside the OpenAPI for defining callbacks. I'm not 100% sure if you can use it for that. There is also an issue for this kind of event-driven architectures. So I also used this OpenAPI specifications in the past, and we had another project where we had to create something where we used MQTT. And then we had also this problem of this real-time communication. OpenAPI does not support it, but there is another standard, it's called async API. And inside async API, you can add those additional protocols.
Another questions? We still have time. If not, I would say thanks a lot for this very interesting talk, and bye.
Yeah, thank you very much.